So people ask me this question as a domain expert, what are the different applications of machine learning, data science or big data? So firstly, when you say domain expert, I would like to clarify that domain expert is in two areas which you actually talk predominantly. One is you can be a domain expert in a particular industry. Okay, like you could be a domain expert in healthcare, you could be a domain expert in telecom, you could be a domain expert in financial services. From the virtue of the past experience which I had, fortunately or unfortunately, I can say myself as a domain expert in the area of AI and big data, but not as a domain expert in any particular industry, because at the same time I got to do a lot of proof of concepts across industries. One interesting concept which I actually did, which can actually give you a good insight about what kind of machine learning or data science application can be built in healthcare, is a problem which I actually solved for the US healthcare market. So we built a US population healthcare management system, and just to give you some context, and when I give this context, hopefully some of you guys will appreciate any data science application or any AI application which you build, the business domain knowledge is very important, that you understand it really well. So knowledge of that area, you may not be an expert like having worked in the industry for 2 years, but you will have to pick up at least the working knowledge before building it. So that's you'll also be able to appreciate that when I actually explain you the entire use case. So this is a post-Obamacare Act. Obamacare Act is one act which President Obama introduced in the US healthcare market, and it was done with the intention of reducing the healthcare expenditure, which was a burden on the insurance companies and the government of US. So they wanted to reduce that healthcare burden without actually compromising on the care being given to patients. So it's really a huge problem that the government had. So in order to solve this problem, after a lot of study and analysis, they decided to start off something known as accountable care organizations. Accountable care organizations, these are organizations which are predominantly where the working staff are nurses, senior nurses, because people who come from the nursing profession after a particular age of 45 or whatever, they actually may not be or may be effective in their job of taking care of the patients. So typically they migrate to a role as a care manager, and an accountable care organization is predominantly driven by care managers. So accountable care organizations can be the responsibility of different kind of organizations, but predominantly what you see, accountable care organization is driven by the payer or the insurance company, or it could be driven by the primary healthcare organization, which is like a large hospital present in a particular area. Or third, it could be driven by a community of people who are living there. For example, if I can take an Indian context example, let's assume all of us staying in area X of Hyderabad decide to start an accountable care organization as a community driven organization. We can actually do it. We are allowed legally to do it. Or it could be an organization started by any of the large health insurance companies specifically to monitor the health of people in our area of residence. Or it could be also driven by a hospital which is present. Let's assume that like a hospital like an Apollo or anyone is present in an organization, they can also start an accountable care organization. So now predominantly the accountable care organization's responsibility is to ensure the well-being of people in the area, and predominantly they look at chronic healthcare disease patients, because chronic healthcare disease patients such as patients suffering from diabetes, hypertension, asthma, obesity, these are people who are actually creating a burden on the healthcare budget of the insurance companies or the healthcare budget of the US government. Okay, and if these people end up in an emergency room situation and they end up in the emergency room of hospitals, it's likely to cause a huge expenditure. So the entire focus of the accountable care organization which we were interacting with, their responsibility was to ensure that asthma patients, both pediatric and old patients, do not end up in an emergency room kind of a situation. So that was the business context, and we decided to build them an intelligent alert system. When I say intelligent alert system, so we were analyzing data from multiple sources for this project, and the multiple sources were healthcare parameters which are coming from internal to the ACO. These are health parameters like the diagnostics tests which the patient has actually given samples for. Second could be data which is collected on the environment and especially related to the pollution, because asthma patients are very susceptible to pollutant levels in the air, which is the pollen level in the air, the NOx, nitrogen dioxide levels in the air, the carbon monoxide levels, the sulfur monoxide levels. So we were collecting this data from government websites like Environmental Protection Agency. We were also asking our patients to wear some health devices like Fitbit or anything which helps us to monitor their physical activity on a daily basis, and they were also incentivized to actually through an app enter information in terms of what kind of food they are intaking and how much dosage of medicine they are taking, how they are modulating that. So they were also incentivized to give us this information on a daily basis. So this was all the different kind of information which we had. So we had actual data coming on the diagnostic tests. We had data which is coming from third-party agencies on the pollutants or anything. We had data in terms of their health parameters coming through wearable devices, and we also collected other parameters such as their compliance to their doctor visits and everything, because these are patients who are suffering from chronic care. So how frequently are they going to the doctor, and when did they make the visits and stuff like that. So combining all this data was the first challenge which we had, and after combining all this, we analyzed the data and built a machine learning model which was actually giving intelligent alerts. Okay, and the intelligent alerts was here. If you look at it, we were predicting the probability whether a patient is likely to end up in a hospital in an emergency room situation, or whether he's not likely to end up in an emergency room situation. And once we actually predict whether a patient is going to end up in an emergency room situation, this used to come up as an alert in the care manager. As I mentioned, care manager are nurses who are part of the accountable care organization, and each care manager was responsible for handling the health of at least 1500 patients. All right. So these people used to get an alert on a particular patient that, hey, we feel that this guy is going to end up in an emergency room situation. That used to be machine learning driven insight. Not only we used to give the machine learning driven insight, we also used to give evidence why we believe this guy is going to end up in an emergency room situation. Like the evidences could be something like as simple as, hey, he is not doing his exercises regularly, or it could be like his levels in the last 2 months of tests were on the higher side. And we just give this evidence, and then the care manager, using his expertise as a nurse and who understands this chronic disease, used to intervene with the patient and ensure that he takes some preventive action or does some action which reduces his chances of ending up in the emergency room situation. So this was one healthcare example of an application like population health which we implemented as part of my previous work experience in the healthcare domain. Similarly, if you look at the financial service industries, there are a lot of applications. Financial service industry has been using data science or any machine learning tools way back from the last 30 or 40 years. Okay, machine learning or anything like logistic regression, decision trees, these are used especially in the retail banking and also in the investment banking side to suggest some business action which results in either reduction of cost or increase in revenue. One example I can take, if you take any retail banking example, let us assume that you as a retail banking or marketing manager, you would want to create a campaign of personal loans. And before creating that campaign of personal loans, you would you would want to understand the probability of a person responding to a personal loan campaign on a phone or an email, because you want to understand that in order to reduce your expenditure on the marketing campaign. So before that, you can ask your team of data scientists or data analysts or business analysts which you have to build this model for you. They will actually take data from multiple sources within the organization, external to the organization. When you say within the organization, it could be data related to savings bank account. It could be data related to his credit card spend or credit card payments. When you say external data, it could be his credit score data which is coming from third-party agencies. It could be his demographic data, which is again the bank is collecting in terms of his location or the kind of company which he is belonging to. It could also be like what is his salary and stuff like that. All these parameters from multiple sources are actually captured, and then they can actually build a machine learning model to predict whether the propensity or the probability of the person to respond pulse to the loan campaign. So this is one example of an application of financial services. There could be several other applications in the area of suggesting investment strategies. Okay, whether to what is the ideal portfolio which you people should have. Okay, so and there could be other areas like who is going to default or do a default on the payments, and there could be other applications of financial services in terms of fraud like credit card fraud or any other banking fraud. We can actually predict, a machine learning model can be used to do that. Apart from financial services, if you look at internet marketing companies, again there are huge applications which are already there. All of us, I'm sure, we have used internet websites or apps such as YouTube, Amazon and so on. In all this, whenever we go into YouTube, there are recommendations which are given in terms of videos. This is again a machine learning example. There are two kinds of recommendation engines. One is a collaborative filtering based recommendation engine, other is a content based recommendation engine. In both these applications, in content based, people understand what is our unique taste and try to recommend videos or try to recommend to us products or try to recommend to us some form of content which is very specific to our likes and preferences which they have been able to understand based on a past behavior. In collaborative based filtering, it's a different kind of approach where we say, hey, this is a guy who likes this. He is similar to another person who also likes something similar. The other person liked an XYZ content or a product, so let us recommend this to him. So that is another application, especially the recommendation which keep coming to you in terms of videos when you see in YouTube, or recommendations come to you in Amazon in terms of a product recommendation, is purely based on this application. So that's another application where the building of the application could be on small data, but definitely the application will be on big data. So this is an application in the internet marketing space. Similarly, if you talk about the telecom industry, churn, attrition modeling, okay, or customer segmentation. Attrition modeling, because telecom industry, especially in the prepaid customers, they have customers who actually take on their come in as a customer, but within a short time span of 3 months to 12 months, they actually exit from the company and take up a SIM of card of another company with the same number, especially the number portability. So can you build a machine learning model to predict which customers are likely to leave your company or take up a SIM card on another company with the same number? If you can do that, then you can actually intervene by giving some marketing strategies and ensure that it does not leave. So this is also some very useful use case in the telecom industry. Apart from this, there are use cases even in the travel industry. There are use cases in every industry. Look, nowadays data science is becoming mainstream. Both small, mid-size and large companies, all three different kind of organizations are looking to see how they can actually use data to compete better, and how they can use data to develop a strategy which cannot be, which will give them an advantage of their competitors or rivals. So data science has huge applications, and people who are actually being employed in this area, they have a challenging area of domain to look at, that they can take it two approaches over here. They can work in different problems across different industries, or they can even choose to work in one industry and become an expert not only in data science or AI, but also it's specific to that industry problems where they have solved different kinds of problems specific to the industry. Like if you take financial industry, there's so many different problems. If you get exposed to all of them, you're really going to be someone who's going to be valuable. Thank you.